Let us start exercise 4.4 of CBSE quadratic equation chapter 4. The exercise is 4.4. Question number 1. Find the nature of the roots of the following quadratic equations. If the real roots exist, find them. You see, the quadratic equation is 2x square minus 3x plus 5 equal to 0. So first of all, we will see the discriminant, that is b square minus 4ac. Here you see b is minus 3, so minus 3 whole square minus 4 into 2 into 5. So 9 minus 40, that is minus 31. So here discriminant is minus 31, that is less than 0. Therefore the roots are imaginary, hence real root do not exist. This will be the answer. Now come to the second part, that is 3x square minus 4 root 3 x plus 4. So discriminant will be b square minus 4ac, that is minus 4 root 3 whole square minus 4 into 3 into 4. So it will be square of 4 is 16 and square of root 3 is 3. So 16 3 ja 48. So 4 into 3 into 4. Again it will be 48. So 48 minus 48, 0. Here the discriminant is 0. So the roots are real, rational and equal. So here we have to find the roots also. Let us proceed. X will be equal to minus, inside the bracket, minus 4 root 3 plus minus root minus 4 root 3 whole square minus 4 into 3 into 4 whole divided by 2 into 3. That will be equal to, this is the discriminant is 0, I already proved. So 4 root 3 divided by 6. So x will be equal to 4 root 3 divided by 6. Solve it, you will get 2 by 3, 2 root 3 by 3. And again you will solve it, you will get 2 upon root 3. So this can be converted into, you see, in the denominator part only 3 is there. So this can also be converted if you just put 3 is equal to root 3 into 3. What is say? You say 3 is equal to root 3 into root 3. So if you divide root 3 to 3 means it is equal to root 3 into root 3. So 1 root 3 will be cancelled. So we are left with 2 upon root 3, 2 upon root 3. You can just put it in bracket. So in place of 3 you can write root 3 into root 3 and 1 root 3 will be cancelled. So you are left with 2 upon root 3, 2 upon root 3. Now proceed to the third part, that is 2x square minus 6x plus 3 equal to 0. Here the discriminant will be minus 6 whole square minus 4 into 2 into 3. That is, discriminant will be equal to 36 minus 24, that is equal to 12. Here discriminant is greater than 0, means positive. The roots are real, rational and distinct. Hence let us find the roots also. X will be equal to minus, inside the bracket you write down minus 6 plus minus root of minus 6 whole square minus 4 into 2 into 3. So you will get 6 plus minus root 12, and it can be further solved. You see the 12, that is 4 into 3. So the square root of 4 is 2. So I have taken it out, 2 root 3. So 6 plus minus 2 root 3 by 4. You solve it, take out the 2 common from here. So inside the bracket we are left with 3 plus minus root 3 whole divided by 2. So again I have written 3 plus minus root 3 by 2. And the value of x will be 3 plus root 3 by 2, and second value will be x will be equal to 3 minus root 3 by 2. These are the two answers of the third part. Now proceed to the question number 2, that they find the values of k for each of the following quadratic equation so that they have two equal roots. You see, find the value of k for each of the following quadratic equation so that they have two equal roots. For equal roots, the discriminant should be 0. So let us put b square minus 4ac is equal to 0. That implies that the b square is equal to 4ac. Here the equation is given, that is 2x square plus kx plus 3 equal to 0. So you see here b is k, so k square will be equal to 4 into 2 into 3. 4 into 2 into 3. So it will be equal to 24. So k square minus 24 is equal to 0, or you can say k is equal to plus minus root 24. That will be equal to 4 6 are 24. The square root of 4 will be 2. So I have taken out from the square root. So plus minus 2 root 6. This will be the answer for first part of the question number 2. Now the second part, that is kx inside the bracket x minus 2 plus 6 equal to 0. Multiply it, you will get kx square minus 2kx plus 6 equal to 0. So for discriminant purpose, you see the roots are equal, therefore the discriminant should be equal to 0. So for that, b square will be equal to 4ac, means minus 2k whole square equal to 4 into k into 6. So 4k square equal to 24k, and this 4 and 24 will be cancelled, and there it will be 6. So k square is equal to 6k. So I have cancelled the k and square of the k square. The square of k has been cancelled. So k is equal to 6. This will be the answer of k for the second part of question number 2. Now proceed to the question number 3. You see, the question number 3 states that is it possible to design a rectangular mango grove whose length is twice its breadth and the area is 800 square meter? If so, find its length and breadth. You see, I have drawn the figure of rectangular plot, that is x is the breadth, so length will be the twice x, area is given that 800 square meters. So I have written here the area is equal to breadth into length, so x into twice x, that will be the 2x square, and it is equal to 800 square meters. So x square will be equal to 400 square meters. So x will be equal to, just take the square root, it will be equal to 20 meters. The length will be equal to twice x, so 2 into 20, that will be the 40 meters. So the length will be equal to 40 meters. Yes, now I have written, yes, it is possible to make the rectangular plot. Now proceed question number 4. Question number 4 states that is the following situation possible? If so, determine their present age. The sum of the ages of the two friends is 20 years. 4 years ago, the product of their ages in years was 48. Now see, let x be the age of one friend. So the age of the second friend will be the 20 minus x. 4 years ago, their ages will be x minus 4 and 20 minus x minus 4, that is 16 minus x. So according to the question, product of their edges means x minus 4 into 16 minus x should be equal to 48. So just I have multiplied it. I got 16x minus x square minus 64 plus 4x, that is equal to 48. So x square minus 20x plus 112 equal to 0. So discriminant D is equal to minus 20 whole square minus 4 into 1 into 112. So you will get 400 minus 448. So here discriminant is equal to minus 48, that is less than 0. Discriminant is minus 48, which is less than 0. So the roots are imaginary. Hence the situation given in the quadratic equation is not possible. Now come to the fifth question. That is it possible to design a rectangular park of the perimeter 80 meters and the area 400 square meter? If so, find its length and breadth. You see, I have drawn a rectangular field whose breadth is b and length is l. So the perimeter will be equal to twice l plus b, bracket close, that is equal to 80. L plus b is equal to 40. Divided by 2, so it will be equal to 40. B will be equal to, means breadth will be equal to 40 minus L. The area will be equal to L into B. So in place of B I have written 40 minus L. So L into 40 minus L is equal to 400. So just to multiply it, you will minus L square plus 40L minus 400 equal to 0. So L square, again I have written it, L square minus 40L plus 400 is equal to 0. So L will be equal to minus, inside the bracket write down minus 40 plus minus root of 40 square minus 4 into 1 into 400 whole divided by 2 into 1. So length will be equal to 40, it will become plus, so 40 plus minus root of 1600 minus 1600 whole divided by 2. So it will become 0. So 40 divided by 2, that is equal to 20 meters. Here the roots are equal because discriminant is equal to 0. Now the breadth B is equal to 40 minus 20, that is 20 meters. Yes, it is possible, and answer is 20 meters and 20 meters.